In this video, I'm going to explain how you can build your own solar system, that you're going to know the components from the start to the finish, from the roof to your main panel box. I want to show you that now. I'm going to be talking about ENPHASE. Everything that we're doing, we're using ENPHASE inverters, micro inverters on the roof. So those are going to come down and feed into this box, and then from this box, we're going to go into a solar switch. So it's a main disconnect switch, and then from here, the main panel is behind this, and it's going to be feeding into the main panel. I've been unable to find any information on YouTube about installing a system on metal roofs, which I think is a huge market because you got a lot of these buildings out in agriculture lands that have these metal roofs on, these pole barns or these agriculture buildings or these pole garages or whatever. Almost everybody puts metal roofs on those, and if they're facing in the right direction, would be very easy for someone to put solar on. There's a ton of houses that have this same roof, the same metal roof on the houses across the United States. I know that, and it could be across other countries as well. So let me start by showing you the components. The first thing you're going to start with is you're going to have an attachment to your metal roof. And let me show you, in this building, we have these as our purlins every 2 foot, and that's pretty common in this type of building. You'll have a purlin every 2 feet up, right? You're going to need to attach this on top of the purlin. And what is this? This is an S5 Solarfoot, and that's what it looks like. When you buy these, you get the nut that goes on top of it that attaches the bracket. I'm using IronRidge. What I would recommend buying, it's probably some of the best in the industry, and they build it to be compatible with IronRidge. You'll place this on top of it, this bracket. You'll take the nut, you'll put it on top of that, right? Then you'll take our rail, and I'll have to pull one out over there and show you what that is, because I'm trying to go from the roof up. Because I'm supposed to have 14 of these. And this is what one rail looks like. The XR10 IronRidge. This would be the top of the rail. This is the bottom of the rail. The way that this hooks up, this will attach to the roof. This will attach here like this. So this is what I'm doing. This bolt slides in like this. This is what it should look like on the roof. This attaches to the metal. This attaches to your Solarfoot. Then it bolts. You put this bolt in, then you'll slide this up over this, and then you'll tighten that down. And this even grips into this. It has teeth on the back of it, so it helps bond it. See how those teeth are there? It'll help bond the entire system together. From there, you'll put another bolt up here. It's called a UFO. I'm gonna grab 2 of these because I want to show you 2 different things. If you were down the system, like if you were down here somewhere, you would just install this. But if you're on the end, you buy one of these little caps. So you would clip this on, then you would slide this, well, you would put it on like this, and that would be your end cap. So that would be what holds down this little lip right there, is what's holding down your solar panel. IronRidge grounding lug. If you want to ground these rails, I bought 2 of these. So you slide this in, tighten it down. Everything has these little ridges on the back of IronRidge that helps bond everything together. So then you would run your copper wire and you run it down to the ground. You can put that here, you can put it down the system, be inside, however you design your system. And before I forget to mention it, I want to make sure to cover this. On the Solarfoot, these 4 screws, this is what you need. They're not provided. So for metal to metal, you need 1.5 to 2.5 inches. We're going metal to wood because we're going into those purlins, which is basically 1.5 inches. But when you take into account, that way I have at least 1/4 inch right here. It won't come through there 2 before. So while we're talking rails, I want to show you this right here. These they're bonding connectors that connect 2 rails together. So you would just take this, turn it over like that right there, and you put it in. You slide it, and then you click it in with that right there. And then you would take your other rail over here, and you would connect it on this side, and then you would have a bonded connection. Something that I forgot to show you is you're going to need these inverter connectors. That's what's going to attach your inverter to your rail. Each one of these have that same little tooth on the back. See those little teeth? So that goes in your inverter. Then it goes onto in the middle of your panel. And that's what's going to hold the inverter upside down on the rail. So I don't know if you can see me from over there. The same thing goes here. You put your inverter upside down, you attach it, and you lock the nut down. Now let's talk about the wiring. This is 27 connectors on this. This cost me nearly 500 bucks. This is an expensive wire when you're talking about what little bit of it that you need, but you have to have this wire to make it work with your micro inverters with ENPHASE. I'm gonna buy you end caps that go on this wire. Once you cut those, because I'm going into 3 branches, so I gotta cut this wire. I'm gonna have to have 3 of these caps. They basically come apart, you put your wire in, and you seal it up, watertight. But you have to have these to close off the circuit. And you're gonna see it in the microinverters here in a little bit. This plugs into the microinverters. And these are made just for ENPHASE. Just a component that you gotta be aware of that you're gonna have to have. Don't use your own wire. It's not gonna work right. End cap, this wiring. It's expensive, but it's gonna make your life a lot easier when you get it on the roof. Another component I would highly recommend are these wire clips. You can use zip ties, but these are UV rated. They're not gonna fail you over time. Zip ties will fail over time. They'll become brittle and they'll break. Then your wires will be hanging on your roof. Definitely don't want wires hanging on a metal roof for sure. And that's the part number. In the description below, I'll put everything, all the parts I used or will be using on this system. Each one of these bags hold 20 wire clips. I'm gonna put at least 3 wire clips on each panel. Something I was gonna mention when I was showing you the wire a second ago is what orientation you lay your panels will depend on the type of wire. They have a landscape and they have a portrait wire. Depending on which way you're gonna lay your panels, whether they're gonna be like this or like that. So we have a roof like this, we're laying with it. I wanna call that portrait. Landscape would be sideways, right? Portrait, straight up and down, landscape. Why that's important is the wire distances are different. Some of them I think is 1 meter, the other one's 1.5 meters. That gives you enough distance to be able to go from one panel to another and kind of wrap back in a U. And that's important that you have the right length when you're building out your array and how you're gonna lay out your panels. What I'm gonna do is lay one panel like this with the top of the panel connector here, and then I'll flip my other panel upside down and have the connector kind of close to one another. You have oversized panels, and I have to get the long wire. I just want to make sure to bring that to your attention if you're building your own, that you need to think these things out. This is something that's very important for a metal roof. I'm going to open it up here and just say it's just a box on the inside, but it's the back side of this thing that's where the magic happens. See this right here? When you've got it attached, you'll take your caulk gun and you'll put it right here, and you can see that little port. It'll fill this cavity with silicone or a really good sealant. And then when it's completely filled, it'll come out this port over here. So you'll know that all this is filled and it's coming out here. It's gonna create a watertight seal that nothing can get through this into your attic. I really think this was a well thought out product. I paid near $70 for this box. There's boxes that go up a couple $100. I just thought they were kind of ridiculous. None of them had this type of system in the back of it, which I think for a metal roof you really need. Especially for a metal roof, you don't want to tear back up and make your flashing around it. You can, it's probably still going to leak. I just think this is going to last for a long time. You got it away from the exposed sun, you know, the silicone. So that should last for a very, very long time. And then you have this rubber seal that will even help seal it too. So I'm going to open this up and show you all the inside of this box. This is what it comes with. There's the inside. So you can install your connection points here. They give you the bolts to fasten down, you know, to make your secure point. So there's where your bolts go in. You know, if you can see the 4 there, connectors here. Transition from that wire I just showed you over to the 12 gauge wire, which is sitting in the floor over there, which I'll get into in a little bit because it's still a roof component, but that's where you make the attachment into this. 3 ports for your wires for each branch coming into this. And then you're gonna have 1 more port for a ground. You're gonna have 2 ports coming out the bottom, which 1 port feeds the 3 branches that we'll have up on a roof and the ground. Because the ground is not gonna be ran in the same conduit because it has to connect to the grounding rod on this structure, and then we'll run the other wires to the other structure. I really like this box. I thought it was worth the 65 or 70 bucks that I paid for it. So you take this 1 bolt right here to access the inside. This is a UniRac Solobox. And I think this is a 2nd generation or something like that, because there was different versions of it, but this is the one that we ended up choosing. Now what happens with this is it kind of, in our design, it kind of sets in the middle of the whole array. And this may look like it don't have enough room, but I want to verify that it does. So let's bring the camera in close and show you that right there. So if you can see here, that's with it setting all the way down. The top of my solar panel would be right there. And if it does look like I would clear that pretty easily with it setting all the way down. So if we adjust that up, it would definitely clear it with no problem. But I would prefer for that to be setting all the way down on that, and I have enough room right there. As long as there's no other obstructions, we're golden. So even if we want to put this under the solar panel, it will work fine. I just wanted to confirm that we do have enough room on an XR10 with a UniRac box. When you're using a Solarfoot and this bracket, this L bracket, with this system, you would still be able to install this under your solar panel. I guess a really important component would be to show you what solar panels we're actually going to install for our array. So let's take a stroll over to the garage where they're actually being stored and show you those. Now I want to talk, if this was the end, you see how that kind of will hold that down? This right here kind of lips over, and that's what attaches the solar panel down. Of course, this solar panel is flipped over and you can't see the glass of it, but that's what it would look like if it was holding it down from the top. So it kind of attaches in. Now if we had this end cap, this would be an end, so you just snap it in, and that's what an end would look like holding down to that. Well, of course that wouldn't be there. It'd be holding it down to the actual IronRidge racking system. So each one of these panels will be converted from DC power to AC power using an ENPHASE IQ7 Plus microinverter. And the way this works is these mount to the IronRidge. These wires here will run to this wire here that comes with your microinverter. This attaches to this right here, this one. And then these plug in like that, and then like that. You can't get the connection wrong. And that's what converts it at the roof. Now that we've figured out our microinverters to our wiring into our UniRac Solobox, we move to the panels because that's the next things that will go on top. I'd say a lot of you guys want to know what panel I'm using because these are kind of hard to find. The black on black on black. These are S-Energy 370s. I'll put the exact model number and everything in the description below. They're roughly 3 1/4 foot wide, 6.5 feet long. So now our next component, and we got a lot. There's a lot into building this. You're gonna need a lot of conduit. You're gonna need Schedule 40 and Schedule 80. If you're running on the outside, you have to have Schedule 80. If you're on the inside, Schedule 40 will work. Something that confused me at first as I was trying to design this and make sure I was doing everything correctly is the grounding. Just go ahead and ground the rails to your grounding electric rod, and then you're gonna have to have a number 6, which I got sitting over here, and I'm gonna show you that in just a second. But you have to have a number 6 copper wire running from the top all the way to your combiner box. Now it's important to understand how you're gonna run your wire from the roof to your combiner box. For me, we're gonna run conduit inside, even up here. We're gonna come down this wall right here somewhere, and then down, and then go outside, which we'll be using that Schedule 80 pipe. And then we're gonna go into the ground, and we're gonna go over to the garage on the house. Because we're burying wire inside of a conduit, we can use this THHN 12 gauge wire. So depending on how you're gonna be running your wires from the roof over to your combiner box, because I'm gonna assume you're gonna be using ENPHASE. If you're watching this video, it's talking about ENPHASE microinverters at the roof. I would highly recommend getting this box that I got. I found it for an awesome deal. It was brand new, and everything with ENPHASE. Let me just stop the video here real quick. Everything with ENPHASE, you can contact their customer service and give them the serial number, and they will tell you if it's brand new or not, because you have to commission everything you do with ENPHASE at the end. So if it's ever been in use, and you want brand new items that's never been used, call ENPHASE customer service and they'll confirm that by just giving them the serial number. All right, so back to what I was trying to say. If we have a wire that's going to be coming in here somewhere, we're going to need to know what that wire is. And on this system, 3 branches, 9 panels per, we can run a 12 gauge wire. The 6 gauge solid copper wire will run from the rails down over to, if you watched our video where we installed that ground rod, this is going to be running to that. Not to the house ground rod. This is going to be to the building ground rod. There's an 8-foot, 5/8 rod drove into the ground. This will connect directly to that. We're using stranded wire. We need 3 runs from the roof to the combiner box on the house. I'm using number 12 THHN wire. This is stranded wire, and I gotta measure these out in 160-foot runs because that's what 500-foot times 3 will be. So I just don't want any wasted wire as far as running it. Whatever's left over at the end, I'll just chop it off. And that one was red. We got a couple more of these LBs just because we may have to have them. Then I got the black, same thing, 12 gauge stranded wire, 500 feet. I'll chop that into 3 sections at 160, around 160, 166 feet each. Then we got the expensive wire, number 6 ground wire. So now we're running another ground from our box that we're going to have on the roof. When we take the 3 branches and put them together, we're going to run a ground from that over to the combiner box. And that's probably around 130 feet when you just count all the conduit it has to run through. But I had bought 150 feet. Yeah, 150 feet. This wire right here was $1.48 a foot when Lowe's compared it to Home Depot. They were trying to sell it for $1.68. Still super expensive because this is $235 for 150 foot. And I still have to buy some expensive wire for number 4 copper. I don't have to have a lot of it, but I do have to have probably 10 feet of the red, the black, and the green. Probably gonna cost me, that's 30 feet, probably 90 bucks, 100 bucks, I don't know. 130 by the time I get to doing it. So here's the run in the ground that we're using. And I dug this when we put the 100 amp box in. If you didn't see that video when we put the 100 amp in, that's actually when I dug the ditch for the solar run as well. It just basically comes down through here and then over to the house right here. And these components are must-have no matter what, if you're setting up a system like I am. Our wires, the number 12 gauge wire is going to be coming from the roof, down under the ground, over, up through this conduit right here. Going to enter here, connect to the branches, and then they're going to come down into our solar disconnect box. Then that's going to go from here into the inside. We're going to have an ENPHASE combiner box 3ES actually. And I'll show you what that looks like on the inside of that in just a little bit. Then from there, we're going into a solar array disconnect switch, which is this right here. We can turn it off if something happens, the fire department ever needs to turn it off quickly. They can just hit that switch and it shuts down the entire system. From there, it's going to enter into our eating box on the inside. Let me open it up. On this, we're going to need 320s. This is for our Envoy. You can see the Envoy, which communicates with the micro inverters, and then we can track everything online of how we're producing. But we're going to need our 3 breakers, which I had to buy. Those are Eaton breakers, just BR breakers. We're fine for that. And here we're going to find it's a ENPHASE IQ combiner 3ES. So that's what this box is. And then from that box, we got to run down through a main disconnect, which this is not hooked up right now. We got to put, this is a fused box, and the model number that I'm using is a DG222 NRB. I got it off Amazon. I'll put a link below if you're looking for one of those for your solar. This is what you need, because you can use different switches, but you want to make sure you're using switches when you go to make your electrical diagram that you can find easily. Most programs will have this box in it. That's why I went with it. This made things a lot easier designing the solar system. For my one-line diagram, electrical diagram that I had to have to get a permit to do this solar, the lines will come from here down, then it would feed this, and then from here, I think the lines will come from this side down. They'll wrap around and they'll penetrate right there into the back side. Right there is the top of the roof, and right here is the entry point for the wires that will go up to the roof. And then we'll have our solar. It'll basically come up. Let me see if I can point from here over to about there. You have to have a 3-foot section on that side, 3-foot section on that side for fire. So if something ever happened in the building, you have access, the fire department has access from each side. And then we got a 1.5 foot on top. Everything else is usable, and we're gonna use almost all of it. I'm not sure if you can see where the screws are going in holding that metal down or not, but if you count 3 screws up, that's where our first Solarfoot will be installed. And then the 5th one up will be the second. That'll hold the first row of panels. Then it'll be number 6, and then number 8. That'll hold our second row of panels. We'll have 14 here and 13 up top in a staggered position. So we're on the inside of the garage from the house, and then from here, we're gonna be entering right there. So it's important that we get these closed, because this has to be accessible at all times. I may have to put another one here, an access point, but if I have to, I will. I'm hoping that I can find some type of solution to run my LB through here, that I can run my wiring through this stud, and I don't have to put another LB here that's open, so I'll have to put another access point. I don't want to do that, so I'm looking for a solution on that. I'll probably have found that by the time I put this video out, but if I haven't, please leave me a comment below. Let me know what my options are from entering there and coming up to the bottom of the box, because we have to come through the bottom of the box, and I don't want it to have another cover right here. One will be enough in that space. I really do not want to, but if I have to, I will. Once we enter the main box, that's going to be where our solar panel back feed breaker is, and that's going to require this breaker right here. Hard to find, very hard to find, because it's a 45 amp breaker, and that's what you're going to have if you're building a system like mine. So that would sit right in there, and that would give you your back feed breaker that's feeding in from the solar panels down. I had to run back over to the building, or over to our big garage, what we call it. This is very important, because you will not pass inspection without having your breaker and all of the electrical components properly marked. You'll have to buy these online. You can buy them from whoever you would like. I'll put a link in the description below where I actually got these, but there's a bunch of stickers in here. We bought a pack, and it just gives you, that's the rapid shutdown switch for the solar PV system. That's that switch I was showing you earlier. It has to have that label on it. This has to be inside of the beside the breaker that I just showed you, the 45 amp. So it's little things like that that a lot of people won't tell you. I'm trying to help you save probably $10,000-$20,000 by installing these systems yourself. We had a quote at $2 a kilowatt. Ridiculous. I don't see how solar can ever take off if people are charging $20,000 to put this up on the roof. That was them putting it on the roof. That was not them buying all these components, building the system, getting it laid out. Anyway, hopefully this saves you a lot of money. If you're going to try to do it yourself, build out the system. And if you can get up on the roof and install it yourself, you can get out of this for a fairly decent investment. I don't see how solar will ever take off with all the quotes that I've gotten. I mean, we've gotten quotes up to $85,000 to build this system. That was with a battery. Let's be fair, I didn't put a battery on this one, so I quoted that with them. They told me $56,500. That's ridiculous. There's no way you can get that investment back over a long period of time. That's taking out a second mortgage on your house to pay your electric, and you still got a meter fee that they don't tell you about. I found this out on my own. These are just things I feel like people are being conned out of, and it really upsets me that it's not being talked about. So I want to talk about it. I want to try to save you some money and help you build your system if you're looking to do these type of things, or if you're looking to do your own solar system. I'll try to help you as much as I can. It's important to note, I bought all of my equipment. I've got everything set up, ready to go. I've been looking for someone to install it on the roof, and a lot of solar companies will not a lot, none of the solar companies will even touch what we've bought because they didn't sell us the material themselves. I bought all this material, almost every bit of it, at a 50% discount versus what any of those companies even quoted me. And we'll get into a breakdown of what this solar system actually cost down the road. I'll make a video strictly just on that, on every component that I bought, what they cost. So stick around, subscribe to the channel for that, because that is coming. I just want to finish the system, know exactly what we have in it. I'm tracking it to every penny that I spend, considering what I paid for it with tax, with shipping, and what those rebates, federal rebates, will be at the end of the year, to give you a real breakdown of what the system costs. 10 kilowatts. Anyway, forgive my rant. I don't think that any solar system is worth $85,000 or $56,500 if you're not connected to the grid. I think if you got a fair price on a solar system, will be $25,000 to $30,000 for 10 kilowatts. That would be doable. You can get your investment back. Being that we couldn't even get in that ballpark range, I decided I'm just going to do it myself. No one's going to get the money. We're just going to save the money, and that's what we want to do, because we get our investment back. Now let's do a quick recap of everything you're going to need from the roof all the way to your main panel. It's how we started this video. It's how we're going to end this video. So we're going to go from having your connection point on the roof with your Solarfoot, your L brackets, your iron ridge. On top of that, you're going to put your micro inverters. You're going to attach those. You're going to connect the wires. You're going to run those wires to that UniRac Solobox. From there, the wires will come down through the attic or off to the side of the building, however you decide to do that. But in this installation, we're going to go through the attic space and then run through Conduit down to the side. We're going to run one wire to an electric rod. We're going to run one wire over here to our ENPHASE combiner box 3S, and then we're going to connect those branches into those three breakers, those three 20-amp breakers, and we're going to feed it down to a main array disconnect. From there, we're going to penetrate the wall into our main panel, and we're going to connect into a 45-amp breaker to be complete. But to get to the complete side of that, there's a lot of things you have to take into consideration. How wide is your array going to be? How tall is it going to be? Are you going to set in landscape? Portrait? Is it going to be staggered, like, one full panel then a half panel over that? Ours is going to be staggered. Some people put them right over top of one another because it's got an even number of panels, or they're doing 3 rows, and you can still do that. I could have done 3 rows of 9 and that would have worked out great, but we didn't have enough room on the roof to do those type of things. These are all things you have to take into consideration, things I can't design for you without knowing your building layout or where your solar panels are going to be setting or be laid down. But hopefully in this video you did learn something. You found out all the components that you need to create a grid tie system with ENPHASE microinverters, something I could not find on YouTube when I was looking, and I hope you found this video and I hope it helped you out. If it did, please give me a big thumbs up, because it really helps out the channel. Leave me a comment below if you got any questions for me, and make sure to share this video with your friends and family. And I appreciate you guys hanging out with me today. I'll catch you in the next one.